Hello friends, welcome to engineering tutorial. Now in my previous few videos I discussed the concept of generation and demodulation of a double sideband full carrier signal, amplitude modulated signal. So also I discussed about double sideband suppressed carrier amplitude modulated signal. So another type of amplitude modulated signal which we are going to discuss today is the single sideband suppressed carrier amplitude modulated signal. It was just discussed in brief during basic concepts of amplitude modulation. You can check that video out in my channel. So today we are going to discuss it in detail. What is single sideband suppressed carrier signal in amplitude modulation? Now, we all know that a double sideband full carrier amplitude modulated signal consists of the carrier signal EC cos omega ct plus both the lower and upper sidebands defined by cos omega c minus omega mt and cos omega c plus omega mt, which amplitude em by 2. This is the double sideband full carrier signal. Now, if we remove the carrier signal or suppress the carrier signal and also suppress one of these two sidebands, okay, one of these two sidebands, either the lower sideband or the upper sideband, we get the single sideband suppressed carrier signal. Okay, single sideband means one sideband is passed only, okay, and the carrier is also suppressed. If we only suppress the carrier signal, we get double sideband suppressed carrier. If we suppress the carrier signal along with one of the sidebands, we get the single sideband suppressed carrier. Now, why should we go for single sideband suppressed carrier signal? Now, both the lower and upper sidebands in an amplitude modulated signal, they contain the same information in complete form. So it does not result in any information loss if we suppress one of the sidebands and only transmit one sideband. Okay, actually if we go for double sideband modulation, amplitude modulated signal, it leads to unnecessary wastage of useful bandwidth, isn't it? We are unnecessarily wasting the frequency range, the channel bandwidth. So why not transmit only one of the sidebands, because it contains the entire information in complete form. So why not transmit only one of the sidebands and save the necessary useful precious bandwidth or frequency range of the channel, which can be used for other transmission purposes. Okay, so for that purpose we go, or the single sideband suppressed carrier transmission method is preferred or is used. Okay, so in single sideband suppressed carrier signal, we either have the lower sideband defined by em by 2 cos omega c minus omega mt, or the upper sideband em by 2 cos omega c plus omega mt. So this is the basic concept of a single sideband suppressed carrier amplitude modulated signal. Now we will discuss about the methods of generation of a single sideband suppressed carrier signal. Okay, so basically there are two main methods used for generation of a single sideband suppressed carrier signal. First one is the filter method or the frequency discrimination method. The second one is the phase shift method or the phase discrimination method. So the first one involves frequency, the second one involves phase. Okay, now we will be discussing each one of them in detail separately in separate videos. In today's video we will be discussing about the filter method or the frequency discrimination method, and the phase shift method we will be discussing in a separate video. Okay, so we have two methods: filter method involving frequency, phase shift method involving phase, and this is for the generation of a single sideband suppressed carrier signal. Now let us discuss the filter method. Now the filter method is also called as the frequency discrimination method. So it involves the frequency component. Now this is the block diagram of the filter method for generation of single sideband modulated signal. We have a multiplier to which the message signal and the carrier signal of unit amplitude is fed. Message signal mt is equal to Em cos omega mt, and the carrier signal of unit amplitude means the amplitude value Ec is equal to 1. It is fed. Now the output of the multiplier is the resultant double sideband suppressed carrier signal. It means the carrier signal is suppressed, only the lower and upper sidebands are passed. This is a DSB-SC signal, the output of the multiplier. Then it is passed through a band pass filter with a suitable sharp cutoff frequency range. Now depending on the frequency range selected, it is decided whether the lower or the upper sidebands is passed. Now please draw this diagram in rough so that you can understand the remaining steps in a better way or get a screenshot of it. So as I said, it consists of the message signal, the carrier signal of unit amplitude, the multiplier and the band pass filter. Now the output of the multiplier is the product of the message signal and the carrier signal of unit amplitude. It is given by Em by 2 cos omega c minus omega mt plus cos omega c plus omega mt. We have just used a trigonometric identity, which is 2 cos A into cos B, which is equal to cos A minus B plus cos A plus B. I have used this formula many times in my previous videos, so I have not written that here. So this is the double sideband suppressed carrier signal. Now out of this double sideband suppressed carrier signal, we need only one of the sidebands, either the lower sideband or the upper sideband, okay, which is the single sideband signal. Now in order to suppress one of the sidebands, we select the frequency range of the band pass filter in the appropriate manner. Okay. Now the band pass filter is a special filter which has a sharp cutoff frequency. Now if the band pass filter has cutoff frequencies from omega c to omega c plus omega m, the lower cutoff and the upper cutoff frequency, then the lower sideband will be suppressed and the upper sideband will be transmitted. Means the output will be Em by 2 cos omega c plus omega mt. This happens when the cutoff frequencies are in the range of omega c and omega c plus omega m. It means the lower sideband is suppressed and the upper sideband is passed. This is the single sideband suppressed carrier signal. Now if the band pass filter has cutoff frequencies, which is the lower cutoff frequency omega c minus omega m and the higher cutoff or the upper cutoff frequency is omega c, then the lower sideband will be transmitted and the upper sideband will be suppressed. So in that case, we have the lower sideband as the single sideband signal, that is Em by 2 cos omega c minus omega m t. So all it depends on the cutoff frequencies, the frequency range that we select for the band pass filter. This selection of the frequency range of the band pass filter determines whether the lower sideband is passed or the upper sideband is passed. So this is the basic concept about the generation of single sideband suppressed carrier amplitude modulated signal using the filter method or the frequency discrimination method, as frequency was involved here. So in my next video, I will be discussing the phase shift method or the phase discrimination method. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, communication and instrumentation engineering. Have a great day. Thank you very much.